If the Milky Way had a heartbeat, what would it sound like in the quiet of your room when the day finally lets go of your shoulders? Hello, and welcome to Space Science Before Sleep. Maybe you have had a long day, or maybe your mind has been busy and full, carrying a little too much light for this late hour. And if that is true, you do not need to push it away. You only need to let it soften slowly, the way fog thins when the air becomes still. You have got nothing to do but rest. Let your breathing slow by a small, gentle amount, as if the air is taking its time to arrive. And let your shoulders loosen as though gravity has decided to be kind. And if it helps, imagine your body feeling a little lighter, not floating away, only settling more comfortably into the place where you are. Tonight we are drifting through our home galaxy, the Milky Way, not as travelers chasing spectacle, but as quiet listeners learning the pace of something vast. If this helps you unwind, consider liking and subscribing. One calm orbit at a time. Now let us begin. There is a way to measure time that makes every human calendar feel like a brief flicker, and it begins with a single slow loop, the path our sun traces as it moves around the Milky Way's center, carried along with everything else in our neighborhood of stars. Our solar system is moving very quickly, but the galaxy is larger than speed can easily explain. So even a fast journey becomes a long one. And scientists estimate that it takes a few 100 million years for the Sun to complete one full orbiter cycle, often called a galactic year. Try not to hold the number too tightly, just let the idea settle that while centuries rise and fall on Earth, the Milky Way keeps a slower rhythm, one wide turn at a time, like a clock that was never meant for hurried minds. In the time it takes for our Sun to finish a single galactic year, continents can drift, climates can change, and whole chapters of life can arrive and fade. And yet, from the galaxy's point of view, it is all part of one calm sweep, one long exhale of motion. Even if you never think about it, you are part of that motion tonight and every night. The Earth turns beneath you, and the Moon continues its patient circling, and the solar system keeps sliding forward through the Milky Way, as if we are on a wide river that never stops flowing, even when its surface looks still. From where we live, deep inside the disk, we cannot step outside and look back at our home in full, so the galaxy can feel like a mystery, made of scattered points of light. But there are quiet ways we have learned to understand the shape we are inside. We know we live in a spiral galaxy, a broad disk of stars and gas and dust, with winding arms that curve out from the inner regions, and we know our sun is not near the center, but farther out in a calmer neighborhood in a small structure, often described as a spur, a gentler lane between larger arms. You can imagine it like this, a city seen from within, where you can walk through streets and hear distant sounds. But you cannot see the whole layout from above, and still, over time, with careful listening, you begin to understand where the busiest avenues are, where the quiet blocks begin, and where the heart of the city must be. When you look up on a dark night far from bright lights, you may see a pale band stretching across the sky, a soft river of starlight. And that river is not the whole Milky Way. It is only the thin slice we can see with our eyes, the brighter corridor of our disk seen edge on. Most of the galaxy is hidden from naked vision. Dust can veil star fields like a curtain, and many stars are simply too faint or too far, and some of what truly holds the galaxy together does not shine at all. Still, even with this limited view, you can sense something gentle and immense, the feeling of being inside a structure so large that it makes your own worries feel small. Not in a dismissive way, but in a comforting way, the way a wide ocean can make a cramped room feel less tight. This is one of the soft truths of a galactic year. It reminds us that motion does not require urgency. Our orbit around the center is not a race, it is a slow drift, and the path is so long that the stars around us will change their relative positions while we move, as if the scenery of the night sky is quietly rearranging itself over deep time. The stars, you know by name, the patterns you recognize, they are temporary arrangements, beautiful but not fixed. And yet the galaxy remains not frozen but coherent, held in a kind of steady flow. Sometimes it helps to picture this orbit as a calm breathing pattern, not because the galaxy is alive the way we are, but because the rhythm is steady, repeating and spacious. Inhale, a long sweep forward. Exhale, another long sweep, and when that slow cycle completes, a galactic year has passed. If you want a gentle image to hold, imagine the Milky Way as a great dark bowl turned upside down in space, and our sun as a small lantern moving along the inner rim, circling patiently, never stopping, never needing to hurry. And as our lantern moves, it also drifts slightly above and below the galactic plane, a subtle bobbing motion, like a cork riding a slow swell, rising and falling over very long spans of time, guided by the gravity of all the mass in the disk. The details are still being refined, and researchers continue to study how these motions unfold, but the overall story remains soft and clear, that the path of our solar system is not a rigid groove. It is a gentle wave inside a larger turning. See, this slow calendar also changes how we think about history. Long before humans looked up and named the constellations, our sun was already traveling. Long before forests became coal and mountains became dust, our orbit continued. And long after our own era becomes a thin layer in the geology of Earth, the Milky Way will still be turning, carrying whatever remains of our solar system along its quiet route. There is no need to make this feel dramatic. It can be calming instead, because the galaxy does not demand anything from you. It does not need you to understand all its details tonight. It only offers you a place to rest inside a larger pattern. For a moment, let your attention widen. Notice the simple fact that you are here breathing on a small world orbiting a star. And that star is orbiting the center of a spiral galaxy. And all of this is happening with a steadiness that does not care about deadlines or unfinished thoughts. If your mind wants to wander, let it wander slowly. If your thoughts arrive, let them pass like small clouds. The galactic year will keep turning whether you watch it or not. And in the next part of our journey, we will drift closer to the idea of spiral arms, not as solid rails in space, but as flowing patterns, gentle currents that shape where stars are born and where light gathers in the disk. Before we drift farther, let your breathing find an easy pace. Again, not forced, not counted, just a little slower than it was earlier, as if the night air is smoothing the edges of the day. When we picture the Milky Way, many of us imagine a neat spiral seen from above, a graceful pinwheel of light, but from inside the disk, the truth is softer and more complicated, and it begins with the spiral arms, not as rigid structures, but as patterns that flow. Spiral arms can be thought of like currents in a wide, slow-moving sea. They are places where stars and gas appear more concentrated, where light gathers, where new stars are more likely to ignite, and yet the arms are not made of the same stars holding hands for billions of years. Instead, stars drift in and out of these regions over time, while the overall pattern persists, like a traffic wave that moves along a road even though the cars within it change. This is one of the quiet surprises of our galaxy. From a distance, an arm looks like a solid streak, but from within it is a shifting emphasis, a gentle crowding of matter, a place where gravity and motion create a recurring shape. Evidence suggests that spiral arms are connected to what astronomers call density waves, ripples of higher density moving through the disk, compressing gas as they pass. And when gas is compressed, it can cool and clump more easily, and where gas clumps, new stars have a chance to form. So the arms are not only pathways of light, they are also workshops, places where the galaxy makes its newest stars. If you have ever watched a river carry leaves around a bend, you have seen something similar, a place where the flow gathers and swirls, making a curve stand out more clearly than the rest. The Milky Way has several major arms, and it also has smaller features, bridges, spurs, and fragments. And from our position inside the disk, it can be surprisingly difficult to count exactly how many arms there are, and where each one begins, ends. Dust blocks our view in some directions, and distance makes star fields blur into one another. Over the decades, scientists have refined the map again and again as new surveys arrive, using different traces of spiral structure, bright young stars, glowing gas regions, and radio measurements of hydrogen. The details can shift with each new set of observations, but the feeling remains. The galaxy is not a simple drawing. It is a layered swirl. Our solar system sits in a quieter stretch, often called the Orion Spur, between two larger arms, commonly named Sagittarius and Perseus. It is not the most crowded place in the disk, and it may be one reason our sky feels relatively stable compared to what the inner galaxy might be like. You can imagine the Orion Spur as a calmer lane between brighter highways, not empty, not isolated, but gentler in density, with fewer of the most extreme events nearby, at least on average. This does not mean the galaxy is safe or unsafe. It only means conditions vary from region to region, and our region happens to be a quieter corridor in a much larger city of stars. Now let us hold the spiral arms as a kind of slow choreography. Stars orbit the galactic center, and gas does too, but they do not all move at the same speed in the same way. Closer to the center orbits tend to be faster, farther out. The motion changes, and the disk behaves less like a rigid wheel and more like a living flow. Within that flow, the arms are patterns of crowding, and those patterns can trigger bursts of starbirth. In places where the arms glow brightest, you often find large clouds of gas and dust, the raw material of stars. These clouds are cold by cosmic standards, and within their densest pockets, gravity begins to gather matter inward. The process is quiet for a long time. A cloud can drift, compress, and fold in on itself, and only later does a new star finally ignite. When that happens, the newborn star can be bright and hot, and its light can illuminate the surrounding cloud, making a region of the arm shine with soft blues and whites in telescopic images. These are stellar nurseries, not tidy places, but busy textured regions, where gas and dust form filaments, knots, and glowing edges. Even if you never see them directly, you can feel their presence in the idea that the galaxy is still making new light. It is not finished. It is still becoming, and even as the Milky Way matures, star formation continues, though evidence suggests the pace can change over cosmic time. Sometimes more active, sometimes quieter, depending on how much cold gas is available and how it is stirred and compressed. Between the spiral arms, the disk can feel more spacious. Stars are still there, gas is still there, but the emphasis shifts. It is like moving from a busy street to a quieter one. And as our sun travels its long orbit, it slowly changes its relationship to these patterns. Over very long spans, stars can migrate, not only circling the center, but also drifting inward or outward by small amounts, guided by gravitational interactions and resonances. Even our sun may not be exactly where it formed, and researchers continue to study how common this kind of migration is across the disk. Again, you do not need to hold the details too tightly. What matters for tonight is the mood of it. The Milky Way is not a still image. It is a slow-motion dance. If your mind likes gentle pictures, imagine the disk as a wide sheet of silk rotating in the dark, and the spiral arms as faint folds that move across the fabric, guiding where the cloth gathers more densely, where it brightens, where new threads of light appear. And somewhere in that turning silk, our sun follows its calm path while you rest. Signature segment spiral arms as a quiet current. Picture the spiral arms as currents you could almost feel if you were drifting above the galactic plane. Not wind, not waves, but subtle regions where the galaxy's material gathers and loosens in an endless flow. Evidence suggests these arms behave less like fixed structures and more like traveling patterns, places where gas is gently compressed, encouraging clouds to cool clump and begin the long silent process of forming new stars. The stars themselves do not stay inside an arm forever. They pass through, spending a while in the brighter lanes, and then drifting onward, while the arm remains as a pattern that outlives any one star. It is a soothing thought that the galaxy can hold a shape without holding the same pieces that order can exist as motion rather than stillness. If your thoughts are busy tonight, you might borrow that idea that you can be in motion without being in a hurry, that you can pass through your own inner currents and still remain part of something steady. A little farther on, we will step into the space between what we can see and what we can only infer, because beneath the spiral pattern, beneath the visible stars and dust, there is an unseen structure that holds the disk together and helps shape its motion. In the next part, we will begin to drift toward that invisible support, and then into the warp and layering of the disk, the subtle ways the Milky Way bends and breathes. For a moment, notice the surface beneath you, the way it supports you without asking for anything back. And let your breathing stay easy and unhurried, because what we are exploring now is gentle by nature, the quiet architecture of our galaxy's disk. From far away, the Milky Way might look like a single flat spiral, like a smooth plate of light turning in darkness. But up close, and especially from within the disk, is layered, textured, and full of subtle structure, like sediment in a slow sea. Astronomers often describe two broad components in the disk, a thinner layer and a thicker layer, and these are not separate objects. They are more like overlapping populations of stars that share the same general home, but move in slightly, different ways, and carry different histories. The thin disk is where much of the bright, youthful activity lives, where gas is more abundant, where star-forming regions are common, and where many stars have more circular orbits close to the main plane. It is the part of the galaxy that feels like a busy neighborhood, full of ongoing creation. The thick disk is more diffuse and puffed up, extending farther above and below the plane, with stars that are often older on average, and that tend to move with slightly different patterns, as if they belong to an earlier chapter when the galaxy was being assembled and stirred. This layering is one of the ways the Milky Way keeps its memories, not as words, not as pictures, but as motion and as chemistry. Stars carry the elements they were born with, and over time the galaxy becomes enriched with heavier elements made inside stars and spread outward when stars shed their outer layers or end their lives. So older stars often formed when the SARS star galaxy had fewer of those ingredients available. Scientists use these gentle differences to reconstruct a story, one that suggests the Milky Way did not simply appear fully formed, but gradually settled into its present shape, building the thin disk over long spans, while the thick disk preserves traces of earlier turbulence, earlier mergers, earlier mixing. None of this needs to feel complicated tonight. You can simply hold the image of a galaxy that is not a single sheet, but a layered landscape, like a calm ocean with currents at different depths. And there is another quiet detail that makes the Milky Way feel even more alive because the disk is not perfectly flat. It bends. It warps. For a long time, many drawings showed the Milky Way as a neat, even plane, but evidence suggests the outer disk rises on one side and dips on the other, forming a wide wave that travels across the galaxy's edge. We do not notice this from our everyday life because we are too close to it, and because the changes are spread across enormous distances. But when scientists map certain kinds of gas, especially hydrogen, the warp becomes clearer. Hydrogen is the simplest element, and in its neutral form, it can be traced by radio observations that slip through dust more easily than visible light, so it becomes a kind of quiet guide for the galaxy's hidden shape. When radio surveys map hydrogen across the Milky Way, they reveal an extended disk of gas that reaches farther than much of the starlight, and within that gas, the bending of the plane shows up like a slow ripple. This is one of the most soothing ideas in galactic structure, that a galaxy can be both stable and flexible, held together, and yet still responding like a wide fabric that can carry a wave without tearing. What causes this warp is still being studied. Evidence suggests it may be influenced by the gravitational pull of nearby satellite galaxies, by uneven distributions of mass, and by the presence of dark matter in and around the Milky Way, all of which can tug gently over time, shaping the outskirts. in ways that are easy to miss if you only look at the bright inner disk. You can imagine the disk as a vast spinning sheet, and at its edges, small, persistent tugs, not harsh, not sudden, but steady, nudging the fabric upward here, downward there, until a wave becomes part of the long-term shape. This does not mean the galaxy is fragile. It means the galaxy is responsive. It moves like a system in conversation with its surroundings. And that is part of the comfort of astronomy, that even on the largest scales, change can be slow and graceful. If you want a calmer picture, still imagine lying under a blanket that is almost perfectly smooth, and then noticing only when you look closely a gentle rise and fall across it, like the memory of a breeze. That is the warp. Not dramatic, not threatening, simply a reminder that the Milky Way is not a rigid object. It is a rotating structure made of many moving pieces. Within this layered and slightly bent disk, the space between stars is also doing quiet work. We often think of space as empty, but the interstellar medium, the thin mixture of gas and dust between stars, is a kind of atmosphere for the galaxy. It forms clouds, filaments, cavities, and soft borders, shaped by stellar winds, by the slow pressure of radiation, and by the after effects of old explosions that happened long ago. Dust grains, tiny specks of carbon-rich and silicate-rich material, can hide whole regions from visible light, which is why infrared and radio observations are so important. They give us another way to sense the structures that the eye cannot see. Behind those curtains, star formation can continue. In the darker patches of the sky, what looks like an absence is often a presence, a dense cloud absorbing light, holding cold gas, waiting for the gentle conditions that allow gravity to gather matter inward. So when we talk about the disk, we are also talking about a cycle gas becoming stars, stars returning material back into gas, and the disk slowly reshaping itself as that cycle repeats over and over across time. This is not a fast process. It is slow enough that it can match the feeling of rest. The Milky Way does not rush to build itself. It accumulates, it recycles, it settles. Signature segment, the warp, as a silk sheet. If you want to carry one image into sleep tonight, let it be this: the Milky Way's disk as a wide sheet of silk turning slowly in the dark, and the warp as a gentle wave traveling across its outer edge. Radio maps of hydrogen suggest that the galaxy extends farther than the bright band we see, and in that extended gas, the plane bends rising and dipping like fabric, responding to a steady touch. Scientists continue to explore what shapes that bend. Some evidence points to the slow gravitational influence of satellite galaxies, and some to the uneven pull of mass we cannot directly see. But you do not need to choose a single cause to feel the calm of it. The important part is the character of the motion. The warp is not a crack. It is a curve. It is the galaxy adapting without breaking, holding together while remaining flexible. And if your own mind feels slightly warped by a long day, you can let it be that way for a while. You can be gently bent by life, and still be whole, still supported, still turning through the night. As we continue our journey, the next step is to move from the visible architecture to the invisible one. Because even a layered disk, even a bent sheet of stars and gas, needs something to hold it together, especially in the outer regions, where motion should, by ordinary expectations, pull things apart. In the next part, we will drift toward dark matter, not as a scary mystery, but as a quiet scaffold, an unseen structure that gives the Milky Way its stability and its shape. Let your jaw unclench if it is holding tension, and let your breath move in a calm loop in and out, because the next idea is not meant to feel heavy, even though it speaks about mass. The Milky Way is full of visible things, stars, dust, glowing clouds. And yet, when astronomers began to measure how our galaxy moves, they found something quietly surprising. The stars in the outer regions orbit faster than simple expectations would suggest. In a smaller system like the solar system, the farther a planet is from the Sun, the more slowly it orbits, because most of the mass is concentrated in the center. So for a long time it seemed reasonable to think galaxies would behave in a similar way, that the farther you go from the bright center, the slower the orbits would become. But when scientists measured the rotation of galaxies, including our own, they found that the outer parts do not slow down as much as expected. The rotation curve, the way orbital speed changes with distance, stays flatter than ordinary visible matter can easily explain. If the Milky Way only contained the mass, we can see the outer disk should be less tightly bound. Over time, those fast-moving outskirts would tend to drift away, and yet the galaxy holds together calmly, steadily. This is one of the places where dark matter enters the story, not as a dramatic twist, but as a quiet necessity. Dark matter is the name given to something that does not emit light, does not reflect light, and is not seen directly by our instruments, the way stars are. We infer it through its gravity, by watching what it does to the motion of visible matter. Evidence suggests that dark matter forms a large halo around the Milky Way, extending well beyond the visible disk, and that this halo contains most of the galaxy's mass. You can think of the visible Milky Way as the glowing surface, and the dark matter as the deeper structure that defines how everything moves. We do not know what dark matter is made of, and scientists continue to search for answers, but its gravitational influence appears again and again in the rotation of galaxies, in the way galaxy clusters hold together, and in the large scale patterns of structure across the universe. For tonight, you do not need to hold the unknown. You only need the feeling of the role it plays in our galaxy. It is an invisible scaffold. It is a quiet frame. It is the gravity that allows the spiral disk to keep turning without flying apart. If you return to the image of the Milky Way as a sheet of silk, dark matter is like the unseen hands, holding the edges, not gripping, only supporting, giving the fabric a stable shape. Or imagine a lantern hanging in the night. You see the lantern's glow, but you do not see the string that holds it. The string is not the lantern, but without it the lantern would not stay where it is. Dark matter is like that string, except it is not a single line. It is a vast presence surrounding and permeating the galaxy's outskirts. This halo is not empty. It likely contained some stars, ancient ones, globular clusters, and long faint streams left behind by past mergers, but its dominant mass is unseen, and because it is unseen, measuring the galaxy's total mass remains challenging. Estimates vary, and researchers refine them as surveys improve, and as we track more distant objects moving under the Milky Way's gravity. If you want soft uncertainty language to hold, you can think of it this way. Scientists estimate that the Milky Way is far more massive than its visible stars alone would suggest, and much of that weight lies in a broad halo we cannot see. This unseen mass shapes our galactic home. It influences how spiral arms behave. It affects how satellite galaxies orbit, and how they are torn apart into stellar streams. It may even influence the warp of the outer disk, because a halo that is not perfectly smooth can tug in subtle ways over long spans. So when we say the Milky Way is still and stable, we are really saying it is stable because it is held by something more than light. There is a strange comfort in that the galaxy's strength is not in its brightness, but in its gravity. That the structure of home is mostly invisible, like the foundations beneath a building, like the bones beneath skin. Now there is another reason dark matter fits our bedtime tone. Because it teaches us to accept what we cannot fully see. The universe is filled with things that do not announce themselves. Some forces are quiet. Some truths are inferred rather than observed directly, and still they can be real, consistent, and reliable. Dark matter, whatever it turns out to be, has been a steady part of the Milky Way's story for billions of years. It has helped shape the galaxy from early times, guiding how matter clumped, how the disk formed, and how the halo gathered. When galaxies were younger, the universe was more uniform, but small differences in density grew over time, and gravity amplified them, drawing matter together into filaments and knots. Evidence suggests dark matter played a major role in that early scaffolding, creating the framework into which gas later fell, cooling and forming stars. So in a sense, dark matter is tied to the very existence of the Milky Way, not as an add-on, but as part of its original structure. Signature segment: dark matter as scaffolding. Imagine the Milky Way as a bright garden built on a hidden framework. You can see the flowers, the glowing stars, the soft clouds of gas, the pale river of the galactic plane. But underneath, there is a support that does not shine. Evidence from how galaxies rotate suggests that most of the mass is not in the visible disk at all, but in a much larger halo, surrounding and holding everything in place. We do not yet know what dark matter is, and scientists are still learning, still testing ideas, still listening for subtle clues. But its role feels steady. It is the unseen scaffolding that lets the spiral keep its shape, the quiet structure that makes a home possible. If you have ever felt that the strongest parts of your life are not always the loudest ones, you already understand the mood of dark matter. Some supports are invisible, some foundations are silent, and yet they can hold for a very long time, letting everything above them drift, turn, and continue. A little farther on, we will let this invisible scaffold guide us into the idea of memory. Because the halo, both in its stars and in its unseen mass, is not only a support, it is also a record. It holds ancient populations of stars and preserved traces of old encounters. And that brings us into the next stage of our story: collisions and mergers, the long, quiet history of the Milky Way, collecting and reshaping itself over time. Let your breath move, the way a tide moves in and out, steady and easy. Because the next part of our journey is about change, but the kind of change that happens so slowly it can feel like a lullaby. When we look at the Milky Way, it is tempting to imagine it as a single object with a single beginning, a clean spiral that formed once and then simply rotated in place. But evidence suggests our galaxy is more like a mosaic assembled over time, shaped by long encounters, quiet captures, and gentle mergers that stretched across billions of years. In the broadest sense, the Milky Way grew by gathering. Gravity pulled material inward, gas-cooled stars formed, and at the same time smaller galaxies wandered near, and some of them were drawn into our galaxy's larger gravitational field. When a small galaxy approaches a larger one, it does not usually fall straight in like a stone. It loops, it circles. It is pulled into repeated passes, and with each pass, tidal forces begin to unravel it. Stars that once belonged to a smaller system are gently teased away, not all at once, but over time, as if the Milky Way is unbraiding a ribbon thread by thread. The result of this process can be seen in stellar streams, long, delicate arcs of stars that wrap around the galaxy, faint and hard to notice with the naked eye, but clearer when mapped with careful surveys. These streams are like handwriting in the halo. They are traces of old companions that were not destroyed in a single moment but slowly dispersed into the larger galaxy. One of the most well-known examples is the Sagittarius dwarf galaxy, a smaller galaxy that is still being pulled apart today. It is orbiting the Milky Way, and as it moves, the Milky Way's gravity stretches it, drawing out its stars into long tidal tails that curve around the sky. To picture this, imagine a small cluster of fireflies drifting near a stronger current, and then, little by little, the cluster lengthens, spreading into a glowing strand. The fireflies are still there, still shining, but their original shape is no longer intact. That is what tidal disruption can do on a galactic scale. It is not sudden. It is patient, and the stars that are released do not vanish. They become part of the halo, part of the Milky Way's wider family. These streams are also useful in another way. Because stars in a stream share a common origin, their motion can help scientists trace the gravitational shape of the Milky Way, including the influence of the unseen dark matter halo. So the very process of merging which builds the galaxy also becomes a tool for understanding it. If dark matter is the scaffold stellar streams are one way, we glimpse the shape of that scaffold by watching how the released stars follow paths through space. The Milky Way likely experienced more than one merger. Some were small, some were larger. Researchers study star motions and chemical fingerprints, to identify these past events, looking for populations that share a common history, stars that move together in unusual patterns, or that carry a chemical signature distinct from the stars born in the main disk. When a group of stars moves in a different way from its neighbors, perhaps on tilted or elongated orbits, or sometimes even in the opposite direction of the disk's rotation, it can be a quiet clue that they arrived from elsewhere. Retrograde motion can feel like a whisper of foreign origin, not a rule break, simply a memory preserved in movement. Chemistry tells memories too. Every star is born with a particular mixture of elements depending on the history of star formation in its birth cloud. In regions where many generations of stars have already lived and died, gas becomes enriched with heavier elements. In smaller, older, or more isolated systems, enrichment can be slower. So when astronomers read the chemical makeup of a star, they are reading the environment that star came from, a kind of time and place recorded in light. In this gentle way, our galaxy becomes legible. Not because it speaks, but because its stars carry their origins with them. The halo, then, is not just a region around the disk. It is a memory space. It holds ancient stars, globular clusters, and remnants of other systems that were absorbed long ago. And those remnants do not always mix perfectly. Sometimes they remain as faint structures for a very long time, streams and shells, and subtle overdensities that surveys can reveal. If you want to feel how slow and calm this history is, imagine walking through a forest where fallen leaves have layered for years. Some leaves are fresh, some have softened into the soil, and some patterns remain visible, rings and patches showing where a tree once stood. The halo is like that, a place where old layers of history remain even as the whole continues to evolve. Now there is also a future memory being written far beyond our lifetime, far beyond any human timeline, but still part of the Milky Way's long story. The Andromeda Galaxy, a large spiral like our own, is moving toward us. In a dark sky, you can sometimes see it as a faint smudge, a soft blur that does not look like much, and yet it contains immense numbers of stars. It is far away in everyday terms, but on cosmic scales, it is a neighbor. Measurements suggest that over billions of years, the Milky Way and Andromeda will draw closer, and eventually the two will merge. This does not need to feel like a crash. The distances between stars are vast, so direct star-to-star collisions are expected to be very rare. Instead, the galaxies will pass through each other their gravity, reshaping them, pulling out long tidal features, and then, over time, settling into a new combined form. It is like two slow clouds overlapping and then becoming one larger cloud, changing shape without any sharp edge. Or like two long melodies blending into a single song. The merged system will not be the Milky Way as we know it today, and it will not be Andromeda either. It will be something new, quieter, broader, and still turning. If you carry a soft thought into sleep, let it be that even large changes can happen without violence, without urgency. The universe often works through patient reshaping. Signature segment. The halo, as a book of streams. If you could step far above the Milky Way and look back with eyes that could see faint structures, you might notice delicate ribbons of stars curving through the halo like threads caught in slow motion. These stellar streams are the remains of smaller galaxies and clusters that drifted too close and were gently unspooled by tidal gravity. One of the clearest examples is the Sagittarius dwarf still being drawn out today, leaving a trail that wraps around our galaxy like a loose ribbon around a turning wheel. These streams are not only beautiful, they are informative. Their shapes and motions help scientists infer the gravitational field they move through, including the influence of the unseen dark matter halo. In that sense, the galaxy writes its history in motion. Mergers become memories. Disruption becomes structure, and the halo becomes a quiet book filled with sentences made of stars, telling the story of how a spiral home is slowly assembled over time. A little farther now, we will continue along this merger story and drift toward the deeper heart of the galaxy. Because as the Milky Way gathered material and absorbed companions, it also shaped its inner regions, building a central bar and a bulge, and guiding the flow of stars and gas toward the center. In the next part, we will begin our calm approach to the core, to the inner dynamics, and to the dim presence at the center, known as Sagittarius A star. Let your breathing stay smooth and uncounted, and if your thoughts feel scattered, you can let them gather around one gentle direction now, because we are going to drift inward toward the center of the Milky Way. Not quickly, not sharply, only with the calm patience the galaxy itself seems to prefer. From where we live, the galactic center is not a bright point in the sky, because thick dust lies between us and the heart of the disk, and visible light struggles to cross that distance, so the core can feel like a hidden place, suggested rather than seen, and yet we know it is there. We know that in the direction of the constellation Sagittarius, the star fields grow denser, the glow becomes richer, and the motions of stars begin to tell a story of a crowded inner region full of gravity, full of long-shaped paths. A spiral galaxy is not only arms and outskirts. It has an inner life. It has a bulge, a bar, an inner disk, and a central region where orbits can become tighter and faster, where the rules of motion are the same, but the environment is different, more packed, more intricate. Astronomers have learned that the Milky Way has a bar-shaped structure, an elongated concentration of stars crossing the inner region. You can imagine it like a gentle bridge of starlight through the middle, a thick lane where many stars follow orbits aligned with that bar, and where gravity can guide gas inward and outward in slow, complex streams. Bars are common in spiral galaxies, and they matter because they reshape the inner galaxy over time. They can stir the disk. They can funnel gas toward the center, not like a waterfall, but like a long, slow drift, a gradual rearranging of where material spends its time. And as gas moves, it can influence where new stars form and how the inner structure evolves. Around this inner bar lies the bulge, a thick swelling of stars that rises above and below the plane. For a long time, people imagined a simple round bulge, like a smooth ball of stars in the center. But evidence suggests the Milky Way's bulge is more three-dimensional and more textured than that shaped by the bar and by the long history of the inner disk. Some studies describe it as having a shape that from the side resembles a box or a peanut, as if the inner region has puffed up and buckled over time, creating a bulge that is not perfectly spherical. Again, you do not need to hold the geometry tightly. The soothing point is that the galaxy's center is not a single simple knot. It is a living arrangement of orbits, a layered choreography of stars moving in patterns that have been sculpted over billions of years. When you drift toward the center in your imagination, you can also drift toward the idea of different speeds. In the inner regions, stars can complete their orbits in far less time than a star like the Sun does. Closer in gravity is stronger because there is more mass packed into a smaller space, and the orbital paths can be shorter, so motion can be quicker, though still calm in the sense that it is steady and predictable. It is like the difference between walking around a wide lake and walking around a small garden. Both are loops, both are journeys, but one takes longer simply because the path is larger. In the center, there is also a presence that is both famous and quiet. At the very heart of the Milky Way lies a compact object known as Sagittarius A star, a supermassive black hole. We cannot see it directly with our eyes. A black hole does not shine on its own, but we can observe the way nearby stars move, tracing tight, fast orbits around an invisible point, as if circling something heavy and concentrated. From those orbits, scientists infer that the central black hole has a mass of about a few million times the mass of our Sun, often described as roughly 4 million solar masses, with the understanding that measurements continue to be refined. This is a large mass, but the region it occupies is small compared with the scale of the galaxy, and that contrast can be comforting, a reminder that even the most extreme objects in the universe can sit quietly hidden, while the larger structure of the galaxy continues its slow turning. Sagittarius A star is mostly quiet in our era. It is not blazing like the bright cores of some distant galaxies. It is more like a dim lamp behind a curtain, present influential, but not filling the galaxy with overwhelming light. Sometimes gas and dust wander too close and heat up as they spiral inward, producing brief flares in wavelengths we cannot see with our eyes. But in general, the center is calm compared to the active hearts of galaxies that are feeding more heavily. Still, there are hints that the Milky Way's center may have been more active in the past. Evidence suggests that long ago the black hole may have had periods when it consumed more material, producing more energetic outbursts, and leaving faint signatures in the surrounding environment. Scientists continue to study structures above and below the galactic plane that might be linked to earlier activity, and they continue to test ideas about how the center breathes over time, sometimes quieter, sometimes more awake. It is helpful in a bedtime story to hold the center as a heartbeat that you do not need to fear. A heartbeat is not an alarm, it is a rhythm. Sagittarius. A star is the deepest gravitational anchor in the central region, guiding nearby stars into their loops, shaping the inner dynamics, while the bar and bulge shape the broader flow. The core is not a single thing. It is an arrangement of many things, all moving, all responding to gravity, all part of the same slow ocean of the Milky Way. If you picture the galaxy as a wide spiral river, the core is like the deepest whirlpool in the middle, not a violent drain, but a steady center around which everything is organized. And if you picture the galaxy as a piece of music, the core is not the loudest note, but the low, sustained tone beneath the melody, a presence you might not notice at first, but that gives the whole composition its weight. The central bar adds another gentle layer to this music, because a bar is not just a shape, it is a dynamic feature, rotating slowly, guiding orbits, and influencing how material moves. Stars in the bar can follow elongated paths, and gas can be shepherded into rings and lanes. This is one reason the inner galaxy can look complex when mapped in infrared and radio. It is a place where structures overlap, where dust hides, and reveals where motion is steady, but not simple. And above and below the plane, the bulge rises like a thickening of the disk, a reminder that the Milky Way is not a flat drawing. It is a three-dimensional home. As we drift through these ideas, you might notice a quiet similarity to your own mind. Your thoughts are not arranged in a perfect circle either. They have layers. They have patterns. They have a center that holds weight, even when it is quiet. And you do not need to resolve everything tonight. You only need to rest within the fact that structure can exist without strain. The Milky Way holds together. Its arms flow, its disk bends, its dark matter scaffolding supports its halo remembers, and its core quietly anchors the whole. In the next part, we will stay near the center a little longer, not to add intensity, but to soften the picture, to linger with the nearby stars that orbit close to Sagittarius A star, and to sense how the inner bar and bulge guide the calm traffic of the inner galaxy. For a moment, let your attention rest on something simple, the small pause between one breath and the next. And as that pause arrives, imagine we are floating inward again, not rushing toward the center, only letting the galaxy's inner quiet come into focus, the way a distant city becomes clearer when you drift closer at night. The core of the Milky Way is not a bright object you can point to with an ordinary telescope, not from our position inside the disk, because dust lies between us and the inner regions like a heavy curtain, and visible light is easily scattered and absorbed. So the center is known through gentler senses, through infrared light that slips through more of the dust, through radio waves that reveal cold gas, and through the motion of stars that behave as if they are responding to a deep, compact gravity. When astronomers observe the inner galaxy, they see a place that is both crowded and intricate, a region where stars orbit in many overlapping paths, where gas forms thick lanes, and clumps where the central bar guides the flow of matter, where the bulge swells above and below the plane, like a slow, rising hill made of starlight. In a calm way, it helps to think of the Milky Way not as a single spinning disk, but as a layered system with an inner engine, not mechanical, not loud, simply dynamic. The bar is part of that engine. It is an elongated concentration of stars, and because it rotates, it can create regions where orbits resonate, where stars and gas settle into preferred paths, and where material can be guided inward, along dust lanes in a patient rearrangement that takes place over long spans. Gas does not move like a solid object either. It responds to pressure, turbulence, magnetic fields, and gravity, so in the inner galaxy it can form arcs and streams drifting through the bar, gathering into rings, breaking into clouds, and sometimes being compressed in ways that encourage new star formation. If you imagine the bar as a slow, stirring spoon in a wide bowl, it is not forcing the contents into a sudden whirl. It is only shaping the gentle circulation, drawing some material inward while pushing other material outward, and allowing the inner galaxy to keep evolving, even when it looks steady from far away. Around the bar, the bulge rises, and the bulge is not a simple sphere. Evidence suggests it has a boxy or peanut-like shape when viewed from the side, likely formed as the bar buckled and thickened over time, lifting stars above and below the plane, and creating a structure that looks almost sculpted, as if the inner galaxy has been folded and puffed into a richer three-dimensional form. This is the mood of inner dynamics. The Milky Way is not a flat diagram. It is a volume. It has depth. It has a central region where different families of orbits overlap, where the bar, the bulge, and the inner disk interact, and where the gravitational landscape changes more rapidly with distance than it does in the outskirts. Near the very center, Sagittarius A star sits as a compact anchor. You do not need to picture it as a dramatic mouth in space. You can picture it as a quiet weight, a small, dense point of gravity that nearby stars loop around in tight paths. Astronomers have watched some of these stars over years and decades, tracing arcs that curve around an unseen focus, and from those curves they infer that a large mass is concentrated in a very small region. That is one of the most peaceful things about the evidence. It is not a single image. It is a pattern, a set of motions that repeat, that can be measured, that fit together like a slow dance. Some of the closest stars complete their orbits far more quickly than our Sun does, simply because their paths are shorter and the gravitational pull is stronger, and yet their motion is still orderly. They do not spiral inward like leaves in a drain. They loop, they return. They keep time in their own way, like hands moving around a clock face that we cannot directly see. And surrounding this central region is a dense environment where gas and dust can accumulate, a place where clouds can be compressed, warmed, and stirred. In some parts of the inner galaxy, the gas can be more turbulent, shaped by strong gravity, and by the collective influence of many stars packed into a smaller volume. But even that turbulence can be understood as part of the galaxy's ongoing circulation, not chaos for its own sake, but the natural texture of matter moving through a complex gravitational landscape. Sometimes, material drifts inward and heats up as it approaches the center, and that heating can produce brief flares in high-energy light that specialized observatories can detect. Those moments are not a constant blaze. They are more like small sparks, short-lived, showing that the core is not entirely still, but also not constantly active. If you hold one gentle phrase in mind, it can be this: the center is mostly quiet, but not silent. And that quiet is shaped not only by Sagittarius A star, but also by the larger inner structures, the bar that guides flow, and the bulge that holds a thick population of stars. It can be comforting to remember that the Milky Way's core is not separate from the rest of the galaxy. It is connected. Material can move inward over long times, and material can also be moved outward, and stars that formed in the inner region can migrate, while stars from mergers can pass through the halo on tilted paths. The galaxy is an exchange, a circulation, a slow mixing. In this way, the core is like the deepest part of a river basin, the place where many flows converge, not violently, but inevitably, because gravity provides the slope, And yet, even in a basin, water does not disappear. It continues, it cycles, it finds new paths. The Milky Way does something similar, with gas cooling and forming stars. Stars aging and returning material to the interstellar medium, and that material joining the larger reservoir that can eventually form new clouds again. If you want to soften the image further, you can picture the entire galaxy as a breathing system, not breathing air but cycling matter. The disk gathers gas. The arms compress it and light it with new stars. Old stars return it. The halo stores the memory of what was absorbed. The core anchors and stirs. And through all of it, dark matter provides the unseen framework that keeps the whole turning coherently. From within our quiet spur, we see only hints of this inner complexity. But the hints are enough to make the picture feel real, because they come from many different kinds of observation that meet in the same story. The Milky Way has a bar. The Milky Way has a bulge. The Milky Way has a central compact mass. The Milky Way has flows of gas and dust shaped by gravity. And over deep time, these parts reshape one another gently, like a landscape eroded by a slow river, always changing, never hurried. If your mind is still awake, you can let it settle into the idea that complexity does not have to be loud. The galaxy's heart can be intricate and still calm. Your own mind can be layered and still safe. You do not need to solve anything tonight. You can simply rest within the larger rhythm. In the next part, we will widen our view just a little, letting the core remain behind us, like a dim lamp in the distance, and we will return to the gentle sense of the whole system, the disk, the halo, the slow recycling of matter, and the sate, feeling of being carried through a vast structure that continues, turning while you sleep. Let your eyes rest where they are, even if they are closed, and let your breathing be the only motion you need to notice for a moment, because now we are going to widen the view again. The way you step back from a painting to see how the colors connect. We have drifted through the slow clock of a galactic year, through the flowing patterns of spiral arms, through the layered and gently warped disk, through the unseen scaffold of dark matter, through the halo's memories of mergers and inward, toward the bar bulge and the quiet anchor at the center. Now, rather than adding new intensity, we will let these pieces settle into one calm picture. A single galaxy that behaves less like a machine and more like a long, patient process. One of the most soothing truths about the Milky Way is that it is always recycling. Stars are not permanent. They form, they shine, they change, and eventually they return material back to the space between stars. Some stars shed their outer layers gently, like a slow release. Others end in brighter events that scatter heavier elements outward. Either way, the result is the same: gas and dust enriched over time, joining the interstellar medium, cooling into clouds, and eventually becoming part of new stars. This cycle is why the Milky Way is not just a collection of stars, but a living system of matter moving between phases. If you could see the galaxy in many wavelengths at once, you would notice that what looks empty in visible light can glow in infrared, and what looks calm in ordinary starlight can shimmer in radio, and what seems like a still background can be filled with faint signals from hot gas from compact, remnants from energetic particles. The galaxy is layered not only in structure but also in the kinds of light it produces. And yet, through all that variety, the overall mood remains slow. Most of the galaxy is quiet most of the time. Most stars are steady. Most gas is thin. Most motion is patient. That is why the Milky Way can be a good bedtime subject. It offers scale and steadiness. Now, there are details we touched earlier that become even more meaningful in this wider view. For example, the halo, which surrounds the disk, holds not only dark matter, but also ancient stars and globular clusters, compact swarms of very old stars that orbit far above and below the galactic plane. These clusters act like time capsules. Their stars can be among the oldest populations in the galaxy, formed when the universe was younger and the chemical ingredients were simpler. By studying them, astronomers refine the story of how the Milky Way assembled itself and how early star formation unfolded. Again, you do not need to hold any specific numbers tonight. You can simply hold the feeling that some lights in our sky are extraordinarily old, older than most familiar narratives, and yet still present, still shining patiently from the halo. There is also a gentle thought hidden in the idea of mergers. When the Milky Way absorbs smaller galaxies, it is not destroying light. It is redistributing it. The stars from those smaller systems continue to exist now on new orbits, sometimes stretched into streams, sometimes mixed into the halo, sometimes settling into the disk. So the Milky Way becomes a home made of many homes. It is stitched together. It is composite. And the evidence suggests this is not unusual. Many large galaxies grow by collecting smaller ones, building their halos, and reshaping their disks through repeated, quiet encounters. This makes the galaxy feel less like a solitary object and more like a community, a gathering, a family of histories layered into one system. And then there is the future, the slow approach of Andromeda. It is easy for the word collision to make the mind tense, but the true process is more like a long gravitational embrace. Over immense time, two galaxies can pass through one another and then settle into a new arrangement. The stars do not need to crash for the shapes to change. Gravity alone can reshape them. Tidal features can stretch out. Orbits can be rearranged. And eventually, the combined system can become a larger, quieter galaxy with a new structure, a new distribution of stars, a new rhythm. There is no urgency in this, no threat. It is simply part of the long story of how galaxies evolve. If you are lying in bed right now, you can let the timescale do the soothing work. Billions of years is long enough that the mind cannot easily grasp it, which means it does not press on you. It floats above your day. It makes your personal timeline feel gently unburdened. This is the gift of the galactic perspective. It does not make your life smaller in a cold way. It makes your life lighter in a warm way. Now, if you want a final calming image for tonight's drift, you can return to the idea of orbit. Everything in the Milky Way is orbiting something. Stars orbit the center. Gas orbits too, with its own texture and turbulence. The Sun orbits in a broad loop. The Sun also bobs gently above and below the plane. Satellite galaxies orbit the Milky Way and are slowly unspooled. Stars in the halo orbit on long tilted paths. Even the stars near the center orbit an unseen point, tracing loops in tight arcs. The galaxy is an orchestra of loops, and the loops continue whether you notice them or not. Signature segment. Sagittarius. A star is a dim lamp. At the very center of the Milky Way, there is a compact presence, a supermassive black hole known as Sagittarius. A star with a mass scientists estimate at a few million suns, often described as around 4 million, with the understanding that measurements are refined over time. It is not a shining beacon in visible light. It is more like a dim lamp behind thick curtains, known through the motion of nearby stars that orbit an invisible focus. Those stars trace arcs that repeat loops, that return a kind of silent choreography that tells us the center is heavy and concentrated. In our era, Sagittarius A star is mostly quiet. It does not blaze like the bright cores of distant active galaxies. It sits as a steady anchor while the bar and bulge shape the inner flow of stars and gas. Sometimes there are brief flares as material drifts closer, but most of the time the center is calm, a low note beneath the galaxy's larger song. If you are still awake, you can let that quiet be reassuring. Even the most extreme object in our galaxy can be mostly still, letting the vast spiral continue its slow, patient turning. As we come closer to the end of this script, we will let the whole journey settle into a soft landing. We will return to where you are now, in your room, in your bed, while remembering that you are resting inside a moving galaxy, held by an unseen scaffold, shaped by long memories, guided by a quiet heart. In the next part, we will gather the final threads and let the Milky Way become what it already is, A calm orbit, around a quiet center, carrying you gently towards sleep. Let your breathing stay soft and natural, and if you notice any tension in your face, you can let it release with the next exhale, as if the night is gently undoing the tight knots of the day. We have been drifting through a galaxy that never stops moving and yet never seems to hurry. And now, as we come closer to our closing, it can help to gather the whole Milky Way into one quiet image you can keep simple enough to rest with, wide enough to feel comforting. Imagine the Milky Way as a slow-turning sea. Not a sea of water, but a sea of stars and dust and gas, layered and textured with patterns that rise and fade like currents, and with a depth that holds more than the surface ever shows. We live inside that sea. We do not look at it from a distance. We look through it. That is why the Milky Way can feel like a mystery, because the nearest stars are clear, but the deeper structure is veiled by dust and distance, and the greatest part of its mass is invisible. And still we have learned enough to feel at home in the idea. We have learned that our sun is on a long, looping path around the galactic center, completing one galactic year over an immense span of time, a cycle so long that the details of Earth can change completely, while the sun remains on the same broad journey. We have learned that spiral arms are not fixed rails but flowing patterns, places where gas gathers and compresses, where star birth becomes more likely, where the galaxy lights itself from within, again and again. We have learned that the disk is layered a thinner region, rich in ongoing star formation, and a thicker region that preserves older chapters, and that the disk is not perfectly flat, but gently warped, bending like a wide sheet, shaped by fine, subtle, long-term tugs. We have learned that dark matter forms an unseen scaffold, a vast halo whose gravity helps hold the galaxy together and helps explain the calm steadiness of its rotation. We have learned that the halo is also a place of memory, containing old stars, globular clusters, and faint ribbons of stellar streams that trace past mergers the quiet evidence that the Milky Way grew by gathering smaller companions over time. We have learned that collisions and mergers, including the ongoing disruption of the Sagittarius dwarf and the far future merging with Andromeda, are not sudden disasters in the way the word collision might suggest, but slow gravitational, reshaping long dances that transform structure over billions years. We have learned that the core is an intricate heart shaped by a central bar and a thick bulge, and anchored by Sagittarius A star, a supermassive black hole that is mostly quiet in our era, known through the steady looping orbits of nearby stars. When you hold all of this at once, the Milky Way becomes less like a list of facts and more like a single calming truth. Home is not still. Home is moving, and motion does not require stress. You can be carried along by a vast pattern and still be safe. In your own life, you might sometimes feel that motion is always a demand, that change is always loud, that time always presses. The galaxy offers a different model. It shows change that is gentle, patient, and constant, like a slow tide. Even the most dramatic events in galactic terms unfold over spans so long that the galaxy has time to adjust, to settle, to become something new without breaking. There is one more quiet layer to this picture, and it is the recycling of matter. The Milky Way is not only a place where stars exist, it is a place where stars are born, age, and return their material to the galaxy. Gas becomes stars. Stars enrich the galaxy with heavier elements. That enriched gas becomes new clouds, and those clouds become new stars, and sometimes planets. This is not only a scientific process, it is also a gentle idea to fall asleep with. Everything becomes part of something else. Nothing needs to cling too tightly to its current form. In the long run, the galaxy is a cycle of making and unmaking. Even in the quiet, even in the darkness between stars, the story continues. You might never see it directly, but tonight, somewhere in the Milky Way, cold gas is slowly gathering into denser pockets. Some of those pockets will collapse. Some will warm and ignite. Some will become new stars, and their first light will begin to shape their surroundings. Elsewhere, an old star is shedding material gently into space. Elsewhere, a dense remnant is orbiting a companion and drawing in matter that glows in wavelengths our eyes cannot see. Elsewhere, a stream of stars continues its long arc through the halo, a soft ribbon that remembers a smaller galaxy that once was separate. These things are happening without needing your attention. They happen the way your heart beats, without asking for permission. They happen the way night arrives, whether you watch the sky or not. There is comfort in that. Your rest does not pause the universe. Your rest is part of the universe. You are one warm animal on one small planet, and your need for sleep is not separate from the cosmic story. It is inside it. If you want to return to the very beginning, to the question we asked, you can hold it now in a softer way. If the Milky Way had a heartbeat, what would it sound like? Perhaps it would not be a drum. Perhaps it would not be loud. Perhaps it would be the slow rhythm of a galactic year, the long loop of the sun, the gentle drift of spiral patterns, the quiet support of unseen mass, the patient reshaping of mergers, and the steady anchoring of the core. Perhaps it would be a sound too low to hear, more like a feeling than a noise, a deep, calm pulse that reminds you the galaxy is steady, and you can be steady too. For a moment, let that settle. Your breath is the closest rhythm. The galaxy is the farthest rhythm. Both can exist at once, and you do not need to do anything to keep either one going. Now, as we approach the end, you can let your thoughts become less specific. You can let the details blur on purpose. You do not need to remember every point. You only need the overall feeling that you are resting inside a slow-turning home held by gravity, wrapped in a vast structure with a quiet heart at its center. If you are still awake, that is fine. If you are drifting, that is fine too. Let your shoulders sink a little more. Let your breathing stay soft. Let the day loosen its grip. And if any thought tries to tug you back into effort, you can let it pass and return to the simplest truth. You have got nothing to do but rest. In the next and final part, we will let this journey close gently, without urgency, leaving you with a calm sense of belonging inside the Milky Way, and then we will step away so sleep can take over in its own time. Let your breathing be the last story we follow, slow and steady, and let the muscles in your hands soften, because you do not need to hold anything tonight. Not the day, not the future, not even the ideas we have been drifting through. The Milky Way will keep turning. That is one of the calmest facts we know. It turned long before you were here, and it will turn long after this moment. And in between, it carries you quietly, without asking you to keep up. Somewhere far beyond the edges of what the naked eye can see, the outer disk bends in a gentle warp, traced by hydrogen, that glows in radio maps, rising and dipping like a slow wave across a spinning sheet. Somewhere within the brighter lanes of the spiral arms, cold clouds of gas are being compressed by passing patterns, gathering into denser pockets where gravity can begin its patient work. Somewhere above and below the plane, the halo holds old stars and compact globular clusters, quiet golden swarms that have been orbiting for ages, and faint stellar streams that remember galaxies that once arrived as visitors and are now part of home. Somewhere in the inner city of the galaxy, the central bar continues its slow rotation, guiding stars and gas into graceful paths, shaping the bulge into a thick, three-dimensional heart. And deeper still at the center, Sagittarius A star remains mostly quiet, a compact anchor inferred from the steady loops of nearby stars, a dim presence behind curtains of dust, holding the central region in its calm gravity. And all of it is held together by something we cannot see, the broad, unseen halo of dark matter, the silent scaffold that gives the galaxy its stability, making the outer rotation curves make sense, allowing the whole spiral to remain coherent. It is a strange and beautiful thought that the strongest part of the Milky Way is not its light, but its gravity, that the greatest portion of its structure is unseen and yet reliable. If your mind is still searching for certainty tonight, you can borrow that lesson. Some things can support you even when you cannot see them. Some foundations are quiet. Some safety is invisible. Now return to the simplest scale. Return to the room you are in. Return to the weight of your body resting on the surface beneath you. You do not need to picture the whole galaxy anymore. You can let the images fade. The point of this journey was never to keep you awake with wonder. It was to give your mind something wide and gentle to drift with until it becomes tired enough to let go. If you want one final image to carry into sleep, let it be a slow orbit. A calm orbit around a quiet center. Not a perfect circle, not a straight line, but a patient loop that continues whether you watch it or not. You are part of that loop, and you are allowed to rest inside it. If a thought arises about tomorrow, you can place it far away, the way you place a distant star in the background. It can exist without needing your attention. If a memory arises from today, you can let it pass, like a faint ribbon in the halo. It can move through you without becoming a storm. And if nothing arises at all, if your mind grows blank and soft, that is the most natural thing in the world. Sleep is not a task. Sleep is a return. Tonight, the Milky Way is doing what it always does. It is turning. Stars are moving. Gas is drifting. Patterns are flowing. The dark scaffold is holding. And you are here on a small world, in a quiet corner of the Orion Spur, resting under the faint river of the galactic plain, surrounded by a galaxy that is vast enough to hold every story and gentle enough to let you be silent. If you are already drifting, let yourself drift. If you are still awake, let that be fine too. You have done enough for one day. The rest can wait. Good night.